and thank you for visiting the City of San Clemente's water reclamation plant. Have you ever wondered what happens to wastewater that results from flushing a toilet, taking a shower, or washing your clothes? The average person uses approximately 55 to 60 gallons of water per day, and today we are going to learn about the various steps in the process used to treat wastewater and what happens to the water after it is treated. The city has approximately 16,343 sewer customers and 171.8 miles of sewer lines. The current water reclamation plant has been in operation since 1991 and operates 24 hours a day, 365 days a year to collect and treat an average of 3.3 million gallons of wastewater per day, or approximately 1.2 billion gallons per year. Wastewater from homes and businesses is sent to the reclamation plant through the sewer system, where it is treated to meet state and federal regulations. The reclaimed portion of the treated wastewater is pumped to local reservoirs and distributed through purple pipes for irrigation, while the rest of the secondary treated wastewater, or effluent, is discharged through the South Orange County Wastewater Authority ocean outfall. The sludge, which is a byproduct of the wastewater treatment, is also treated through solids handling processes. This process produces approximately 4,000 tons per year of stable material referred to as biosolids. After treatment, this material is sent to a composting facility for beneficial reuse. There are 5 steps in the wastewater treatment process. The first step is called preliminary treatment. Preliminary treatment occurs in the location at the plant referred to as headworks. The first process that the waste stream goes through is the bar screening process. The bar screen captures larger debris from the waste stream, such as wood, paper, toys, and plastic that are too big to flow through the openings of the bar screen. Then a bar rake scrapes the captured debris off of the bar screen and distributes it onto the conveyor, where it is compacted and dumped into bins for disposal at the landfill. The second and final part of the preliminary treatment process is grit removal. After the waste stream passes through the bar screen, it flows into a grit chamber. Compressed air is diffused into the channel, which causes the waste stream to bubble and roll. This rolling dynamic causes the heavy and mostly inorganic materials, such as rocks, gravel, and seeds, to settle to the bottom of the grit channel, where it is then pumped into a grit washer and distributed to bins to be disposed of at the landfill. The second step in the treatment process is primary treatment, which consists of primary settling and scum removal. From the grit chamber, the wastewater then flows through a splitter box, and the waste stream is split between 3 or more primary sedimentation tanks. As the waste flows through the sedimentation, the heavy organic material referred to as settlable solids settles out to the bottom of the primary settling tanks. Each tank is equipped with a fiberglass flights and plastic chains that scrape the bottom of the tank to settle solids into a hopper, where they are pumped to the solids handling process. The flights and chains also act as a conveyance for the floating debris in wastewater called scum. Scum is made up of fats, oils, grease, hair, and soap. The flights push the scum into a trough, and the trough discharges it into a rectangle basin called a scum pit. After the scum pit fills, the scum is pumped to the solids handling process. The third step in the treatment process is secondary treatment, which consists of activated sludge and secondary settling. The activated sludge contains aerobic bacteria that consumes the suspended solids that are present in the waste stream. As the organisms become heavier, more bacteria, called filaments, link the organisms together to form a flock. The activated sludge basins are designed to allow the waste stream to flow to secondary settling basins. The secondary settling basins are engineered similar to the primary settling basins. The difference is the secondary basin flights and chains move the settled flock that was formed by the activated sludge process to a large open sludge pit. From the sludge pit, a portion of the activated sludge is returned to the aeration tanks for bacteria regrowth and is called return activated sludge. The remaining sludge is sent for thickening in the solids handling process and is then called waste activated sludge. A portion of the remaining water, called secondary effluent, is sent to the Saukwa ocean outfall, and another portion flows to the next step in the treatment process. The fourth step in the treatment process is tertiary treatment, which consists of 8 sand filters and 2 chlorine contact basins. The secondary effluent that is not discharged to the Saco outfall is filtered through sand filters, removing remaining bacteria, after which it flows into the chlorine contact basins where chlorine is added to further disinfect the water for potential viruses. The fifth and final step in the treatment process is solids handling, which consists of thickening, digestion, dewatering, and sludge hauling for composting. As mentioned in the wasting step, the waste activated sludge is sent to the belt press for thickening. Once thickened, it is pumped to the digester to blend with the primary sludge and scum from the other steps in the process. The sludge remains in the digester for 20 days, where anaerobic bacteria stabilize and break down the material to form methane gas in a stable material referred to as digested sludge. The digested biosolids are then pumped to the dewatering centrifuge, where polymer is added and water is displaced to form what is referred to as cake. The cake is loaded into haulers and is taken to a composting facility for beneficial reuse. Thank you for joining us to learn about the processes involved in treating and recycling wastewater at the city's water reclamation plant. We look forward to continuing to serve the residents and businesses in the city of San Clemente.